Today, we are going to delve into the world of Adder-Subtractor circuits. These are versatile digital circuits that perform both addition and subtraction operations using a single control signal. The basic concept behind these circuits is that a minus b is equal to a plus negative b. Subtraction is achieved by adding the 2's complement of b. A control signal determines whether the circuit performs addition or subtraction. A control signal of 0 indicates addition, while a control signal of 1 indicates subtraction. The 2's complement method is used to perform subtraction using addition. The first step is to invert b, which gives us the 1's complement. We can achieve this by using XOR gates with the control signal to selectively invert the bits of b. The 2's complement is then calculated by adding 1 to the 1's complement. The key components of an adder-subtractor circuit are full adders, XOR gates, and a control signal, which is denoted by M. When M is equal to 0, the circuit operates in addition mode. When M is equal to 1, the circuit operates in subtraction mode. Here is the logic for a 4-bit adder-subtractor. For each bit position I, B prime I, which is the modified bit of B, is equal to Bi's or M, where M is the control signal. Ci is the carry input to bit I. Si, which is the sum, is equal to Ai's or B prime I's or Ci. The initial carry C0 is equal to M, which is the initial carry for 2's complement. Here's a simple truth table to illustrate how the XOR gate works in the adder-subtractor. When M is 0, the operation is addition. The B input passes through the XOR gate unchanged, so the B output is B. When M is 1, the operation is subtraction. The B input is inverted by the XOR gate, so the B prime output is B bar. The XOR gate performs the operation B prime equals B's or M. Overflow occurs when the result of an addition or subtraction is too large to be represented with the available number of bits. The overflow logic is defined as V equals Cn minus 1s or Cn, where Cn minus 1 is the carry into the most significant bit, or MSB, and Cn is the carry out of the MSB. If V equals 1, it indicates overflow. Adder-subtractor circuits have many key applications. These circuits are used in arithmetic logic units, microprocessors, and calculator circuits. The advantages of adder-subtractor circuits are hardware efficiency, as they use a single circuit for dual operations, and cost effectiveness, due to reduced component count. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.